Hi students. So in last video, we learned some important points related to vectors. Up to resolution of vectors we learned. Now in this video, we will continue the concepts, that is problems related to the resolution of vectors, including the Lami's theorem. Right. So in last class we discussed regarding the resolution of vectors. That means for two-dimensional objects, for example, let us consider x-axis and y-axis. Let us consider a force F is resolved into the two parts along x-axis and then y-axis. It is angle theta. So if it is F cos theta or simply Fx cos theta, and this component become Fy sin theta. Right. Now for example, కొన్ని న్యూమరికల్స్ ఎలా ఇస్తారంటే let us consider example 1, a block which is placed on the horizontal surface. The block mass is m. Let us consider. So on this box, in single direction, in one direction the force is applied, for example. Then the box will move in only one direction. Along x direction it will move. There is no y component. There is no perpendicular component here. Only ఒకే డైరెక్షన్ లో బ్లాక్ అనేది మూవ్ అవుతుంది. సో నో నీడ్ టు రిజాల్వ్ ద కాంపోనెంట్స్ హియర్. సింగిల్ ఫోర్స్ ఆల్వేస్ అప్లైడ్ ఇన్ దిస్ డైరెక్షన్, దట్ ఈస్ Fx. ఓన్లీ x డైరెక్షన్ లోనే ట్రావెల్ అవుతుంది. Now the same box is placed on the same horizontal surface only, box mass m. Now the force is applied in this direction. That means simply the box is pulled with some force. కొంత ఫోర్స్ తో మనం బ్లాక్ ని పుల్ చేస్తున్నాం. In this situation, this entire force is resolved into the two components. ఎలా రిజాల్వ్ అవుతుంది? Let us see. For example, let us consider here horizontal x axis and then y axis. మనం ఎప్పుడైనా సరే ఆ కాంపోనెంట్స్ ని రిజాల్వ్ చేయాలి అంటే ఫస్ట్ x axis y axis ని కన్సిడర్ చేసుకుంటే ఈజీగా రిజాల్వ్ చేసేయచ్చు. That means here F magnitude ఉన్న F bar అనే force, how much amount of force is contributed on the x axis, how much amount of force is contributed on along the y axis అన్నది మనం ఇప్పుడు క్యాలిక్యులేట్ చేయాలి. So for example, here it is considered as angle theta. Here the angle is theta makes some angle with x axis. So if you can draw the perpendicular on the x axis, if you can calculate cos theta, here this component become Fx cos theta, touching angle here. Angle makes some angle with horizontal kabatti ee angle manaki cos theta ayipotundi. Then the remaining angle become Fy sin theta. Well, so this is the resolution of vectors along x direction and then y direction. Now another example 2. Now the same box is placed on inclined plane. Very important. Inclined plane. The same box mass m is placed on the inclined plane. Now here the resolution of vectors ఏ డైరెక్షన్ లో ఎంత ఫోర్స్ అప్లై అవుతుంది అన్నది మనకు రిజాల్వ్ చేయగలగాలి. Right. So again, same point here also. Let us consider x-axis and y-axis. Y-axis and x-axis ni consider cheskundam. It is y-axis. Right. So now here it is angle theta. Here angle is in between horizontal line and inclined line. Very important point, students here. So here theta is angle in between horizontal line and inclined line. So here block of mass m. So the entire weight of the block is applied in the downward direction. మొత్తం weight అంతా కూడా ఇలా downward direction లో ఉంటుంది. That is W is equal to mg. So ఇప్పుడు mg ని మనం two components కింద రిజాల్వ్ చేయాలి. How much amount of mg అనే ఫోర్స్ x డైరెక్షన్ లో ఎంత రిజాల్వ్ అవుతుంది, y డైరెక్షన్ లో ఎంత రిజాల్వ్ అవుతుంది, రిజల్యూషన్ ఆఫ్ క్యాలిక్యులేట్ చేస్తాం. ఈజీ. హియర్ చూడండి. So to resolve this entire to resolve the components, first of all we have to locate the theta ఎక్కడ వస్తుందో మనకు లొకేట్ చేస్తే cos theta sin theta ని ఈజీగా క్యాలిక్యులేట్ చేయొచ్చు. ఈ లైన్ మనం ఇక్కడ this line is act as a normal for horizontal line. ఈ లైన్ మనకి ఇక్కడ హారిజాంటల్ లైన్ కి నార్మల్ గా యాక్ట్ చేస్తుంది. At the same time, this y-axis is act as a normal for inclined line. These two are simply act as a normals. For what? For one is horizontal and one is inclined. So, ఎప్పుడైతే ఈ two lines కి మధ్యలో angle theta అయ్యిందో, then automatically the angle in between the two normals also theta. I repeat once again. If the angle in between the horizontal line and the inclined line is theta, if you can draw the normals for the horizontal line, this is the normal for horizontal. And if you can draw the normal for this inclined line, this is the normal. ఈ line is normal గా ఉంది, perpendicular గా ఉంది. Perpendicular line ని draw చేయగలిగితే, those, angle in between those two normals also equal to theta. Theta అవుతుంది. This, you know, if you know the theta, you know, where is cos theta and where is sin theta. So here it is a touching angle. This component become mg cos theta. mg resolve అయిపోతుంది. mg two parts కింద resolve అయిపోతుంది. So here it is a touching angle, it become cos theta, and along x direction it is mg sin theta. So మీరు గుర్తుపెట్టుకోవాల్సిన పాయింట్ అలా పొజిషన్ ఆఫ్ ద theta. అది గుర్తుపెట్టుకుంటే very easy to resolve the components. Clear? Now the same block, same resolution of vectors in example 3 చూద్దాం. Right. Let us consider a simple pendulum. Resolution of vectors in case of simple pendulum. Simple pendulum means a bob. Pendulum consists of a bob, metal bob of mass m. It is suspended from the rigid support. From fixed support, it may be suspended with the help of a string or a rope. Generally, string lo apply a force ఏంటండి? Tension force. In this situation, this position of the bob is called as mean position. Now, this pendulum is pulled with some force. కొంత ఫోర్స్ తో నేను ఈ సింపుల్ పెండ్యులమ్ ని పుల్ చేశాను. In this direction, I pulled this pendulum. In this direction, I applied some force H and pulled the bob of the pendulum. So ఎప్పుడైతే మనం పుల్ చేసామో ఆటోమేటిక్ గా హియర్ యాంగిల్ బికమ్ theta. యాంగిల్ theta అయిపోతుంది. Now this length of the string let us consider L. Right? Now how much distance it was pulled? ఎంత distance మనం పుల్ చేసాము? Let us consider distance is r. r అనే distance మనం పుల్ చేసాము అనుకుంటే జాగ్రత్తగా అబ్జర్వ్ చేస్తే మనకి ఇక్కడ ఒక రైట్ యాంగిల్ ట్రయాంగిల్ ఫామ్ అయిపోయింది. Right. Now we have to resolve this. The tension force. String లో ఉండే tension force ని మనం ఇప్పుడు రిజాల్వ్ చేయగలగాలి. Before resolving, we have to observe how many amount of forces are applied on the bob. ఎన్ని forces apply అవుతున్నాయి? Let us consider the bob mass is m. Then in the downward direction W, weight is there. Weight is applied in the downward direction. And right side direction horizontal force is applied. 2 forces, and one more force is tension force along the string. Total how many forces? 3 forces are applied on the bob. But still this bob is in the state of a rest. Bob rest lone undi. Why? Because here 3 forces are in equilibrium state. 3 forces equilibrium state lo unnai kabatti this bob is in the state of rest position lo untundi. Now we have to resolve the components. What is the use to resolve the components here? ఇక్కడ ఎలా ఉంటుందంటే ప్రాబ్లమ్స్ చేసేటప్పుడు మనకి they will give the weight of the bob. They will give, for example, like 14 newtons weight ఇచ్చేస్తాడు. Then find tension force and horizontal force అని అడుగుతాడు. Find tension force and horizontal force. So for that purpose we have to resolve the components. Let us see. ఒకసారి మళ్ళీ డ్రా చేసుకుందాం డయాగ్రామ్ మనం. Right. Let us see. Here 3 forces are applied: horizontal force, mg and tension force. Now which force we have to resolve? Only tension force ను మాత్రమే మనం ఇక్కడ రిజాల్వ్ చేయగలం. Why? Because if you can consider x-axis and y-axis, this is x-axis, and if you can consider y-axis also, here mg and horizontal force already on x-axis and y-axis వాటి మీదే ఉన్నాయి కదా. ఇంకా వాటిని మనం స్పెషల్గా ఏం రిజాల్వ్ చేస్తాం? అప్లైడ్ ఫోర్స్ h along the x direction ఉంది. So mg is always in the downward direction, along y direction. Now we have a single possibility, we can resolve only the tension force. Tension force nu maatrame manam resolve cheyagalem. So this tension force can be resolved into the two directions, along x and along y. You know very well. Here it is theta. Here it is theta. Let us consider a straight line. For example, y axis ni manam straight line ga teeskunte, two straight lines are like this. Mathematical rule. So let us consider a line, straight line. Here it is angle theta. Ee angle theta ainappudu this angle also become theta. If you can apply this mathematical rule here, this is theta and this angle will become also theta. Ee angle kuda manaku theta ayipotundi. Once you know the position of the theta, you know how to resolve which one is cos, which one is sin. నేర్చుకున్నాం మనం already before example లో, right కదా. So here it is a touching angle theta. This entire tension was resolved into the two parts. In the upward direction it become t cos theta, touching angle, right? Cos theta. Then the remaining angle is t sin theta. Completed. Right now? Right. Let us see the simplifications to them. Here entire horizontal force is balanced by the t sin theta. Horizontal force ఈ డైరెక్షన్ లో ఉన్నప్పుడు దీన్ని ఎవరు బ్యాలెన్స్ చేస్తూ ఉంటారంటే t sin theta బ్యాలెన్స్ చేస్తూ ఉంటుంది. So from the diagram, from the figure, you can write t sin theta is equal to h, horizontal force, and this entire mg is in the downward direction, is balanced by the upward force is t cos theta. So you can write t cos theta is equal to mg. So if you can simplify this, let us consider equation 1 and let us consider equation 2. For example, if you can do 1 by 2, first equation and second equation to division cheste, you will get t sin theta by t cos theta, which is equal to h, horizontal force, by mg. T will get cancelled. That means sin theta by cos theta nothing but a tan theta. Tan theta is equal to h by mg ane formula మనకు. Clear? So from this formula you can calculate horizontal force when they will give theta, and if you can calculate tension force also when they will give weight of the object, for example like 40 newtons or 50 newtons, like that. And one more calculation part you can do here. Can calculate sin theta and cos theta. Sin theta ni cos theta ni kuda మనం ఇక్కడ calculate చేయొచ్చు diagram నుంచి. Why? Here you framed right angle triangle. ఒక right angle triangle మనకి form అయింది. Here it is angle theta and 90 degrees here, and here it is angle theta. ఇక్కడ theta ఉంది కాబట్టి you can calculate sin theta and cos theta. జాగ్రత్తగా అబ్జర్వ్ చేయండి. Here it is a right angle triangle and this become hypotenuse. ఇది మనకి hypotenuse కింద యాక్ట్ చేస్తుంది. Hypotenuse value is L, and how much distance the bob was pulled, R అనే distance ని మనం ఏం చేసాం, rope ని pull చేసాం. It is the distance, one of the side of the right angle triangle, and it is a hypotenuse. Then this side become root over L square minus R square. How? Generally ఇది చెప్పారు. Generally hypotenuse square L square, hypotenuse square is equal to one of the side is R square plus another side. ఈ side value మనకి తెలియదు. Let us consider that is p square అనుకుందాం. So here p square is subject, p square become L square minus R square, p becomes square root of L square minus R square. P is nothing but another side. Simple గా చెప్పాలంటే adjacent side for the theta. Right now you have opposite side for the theta, you have adjacent side for the theta, you have hypotenuse for theta for the right angle triangle. Sorry. Right, now you can calculate sin theta is equal to opposite R by hypotenuse L. Clear na? Now you can calculate cos theta, adjacent side, theta ke adjacent side and root over L square plus R square by hypotenuse L. Again you can calculate sin theta by cos theta, it become tan theta. So tan theta is equal to sin by cos become R by root over L square minus R square. Completed. So these are the different formulae for the simple pendulum to calculate tension force in the string and horizontal force which is used to pull the bob of the pendulum, you can calculate angle sin theta or cos theta and or tan theta. Right. Let us see a small example based on the simple pendulum. Here the bob was pulled with some horizontal force H. It makes 30 degrees angle with the vertical, and the weight of the bob they gave 20 newtons. If weight of the bob is 20 newtons, find horizontal force and tension is the question. Right? Yes. Here we have to resolve the entire tensional force into the two directions. Here it is 30 degrees. This angle also become 30 degrees. Then this component is t cos 30 degrees. And this side become t sin 30 degrees. You know which forces are balanced here. Just now we discussed it right now. So H is equal to t sin 30 degrees. H is equal to t sin 30 degrees. From this tension force T is equal to H by sin 30 value is 1 by 2, which is equal to 2H. T is equal to 2H is a condition, small condition. And one more, forces. If you can balance vertical forces, mg is equal to t cos theta, means t cos 30 degrees. mg they gave 20 newtons right now. 20 newtons is equal to t into cos 30 value is root 3 by 2. From this, therefore tension force T is equal to 40 newtons, means 40 by root 3 newtons. Tension force T is equal to 40 root 3 newtons. Tension force వచ్చేసింది మనకి. If you can substitute this tension force in this equation, let us consider equation 1. One implies here tension force is 40 newtons by root 3 is equal to 2H. If you can cancel 2 table in 40 to 20 times, therefore horizontal force is equal to 20 by root 3 newtons. So this is the way to calculate horizontal force and the tension force if they will give angle including the weight of the object. Right. Now let us discuss about the Lami's theorem. Actually here Lami's theorem is one of the application of triangular law of vector addition. అక్కడ మనం ఆల్రెడీ నేర్చుకున్నాం రిగార్డింగ్ ఈక్విలిబ్రియం స్టేట్ ఆఫ్ ద బాడీ. సో ట్రయాంగులర్ లా ఆఫ్ వెక్టర్ అడిషన్ లో ఫర్ ఎగ్జాంపుల్ టూ వెక్టర్స్ a bar and b bar అనే two vectors are in the same order which are act as two sides of the triangle. A bar and b bar are two sides of the triangle which are in the same order. Then what is the resultant? The resultant is nothing but the third side of the triangle which is in the reverse in order. This gives resultant for us. R bar is equal to A bar plus B bar. So the same triangular law of vector addition manam, for example here three forces are in the same order, okay order lo unte, for example this R bar is also in the same order, then A bar plus B bar plus R bar become 0 అని నేర్చుకున్నాం. So Lami's theorem అనేది ఏం చెప్తుందంటే మనకి let us consider a particle on the particle three forces are applied, for example F1 bar, and another force is applied that is F2 bar, and the third force is also applied that is F3 bar. ఈ త్రీ ఫోర్సెస్ అనేవి మనకి ఒక పార్టికల్ మీద అప్లై అయినప్పుడు, సో హియర్ అప్లైడ్ ఫోర్స్ ఈజ్ ఆల్వేస్ డైరెక్ట్లీ ప్రపోర్షనల్ టు సైన్ థీటా అని మనకి లామిస్ అని ఆయన చెప్పాడు. దట్ మీన్స్ వాట్ ఈస్ ద మీనింగ్ ఆఫ్ F ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు సైన్ థీటా? F by sin theta is always equal to constant అని దీని మీనింగ్ అన్నమాట. కాన్స్టెంట్. సో లామిస్ ఏం చెప్పాడమ్మా? F is directly proportional to sin theta అని చెప్పాడు. When the three forces are applied on the particle, when the particle is in equilibrium state లో ఉంటే, రెస్ట్ లో ఉంటే, F is directly proportional to sin theta అని చెప్పాడు. That means statement is ఎలా నేర్చుకోవచ్చు అంటే, so Lami's theorem stated as the ratio of magnitude of any one of the force. Ratio is nothing but a P by Q form. Ratio of magnitude of any one of the force to to sine of the ratio, sine ratio, sine of the angle in between the two other forces is always constant అని చెప్పాడు. అంటే ఏంటి? ఫర్ ఎగ్జాంపుల్ magnitude of any one force కన్సిడర్ చేసుకుందాం. ఫస్ట్ ఫోర్స్ ఈజ్ F1, magnitude of F1 bar is F1 అవుతుంది. సో ద రేషియో ఆఫ్ magnitude of F1 and the angle in between the two other forces, ఆ ఫోర్స్ కాకుండా మిగతా టూ ఫోర్సెస్ కి మధ్యలో ఉండే యాంగిల్ ఏదైతే ఉందో ఈ యాంగిల్ F1 కి, దట్ యాంగిల్ సైన్ ఆఫ్ దట్ యాంగిల్ సైన్ థీటా ఈజ్ ఆల్వేస్ కాన్స్టెంట్ అని దాని మీనింగ్ అన్నమాట. అలానే ఈ రిమైనింగ్ టూ ఫోర్సెస్ కూడా మనం అప్లై చేస్తే లెట్ us కన్సిడర్ దిస్ యాంగిల్ ఈజ్ ఆల్ఫా, ఇట్ బికమ్ ఆల్ఫా. ఓకే, and one more, the magnitude of the another force F2 అనే వెక్టార్ కి magnitude ఎంత అవుతుంది? F2 అవుతుంది. By ratio, ratio of magnitude of F2 to the angle in between the two other forces అంటే F1 కి F3 కి మధ్య ఉండే యాంగిల్ బీటా అనుకుంటే, right? So F2 by sin beta is also equal to constant. And one more, third force is F3, magnitude of F3 by the angle in between the two other forces F1 and F2. Let us consider this angle is gamma, that is sin gamma is always constant. So from this you can rewrite as F1 by sin alpha is equal to F2 by sin beta is equal to F3 by sin gamma. So this is the formula to calculate magnitude of the different forces F1, F2, F3 with the help of a Lami's theorem. Right. Now a small example based on Lami's theorem. Here one particle of mass, for example 9 kilograms. So the weight of the particle become mg is 90 newtons. So this entire 90 newtons weight is balanced by the two forces, those are T1 and T2. If these three forces are in equilibrium state, find T1 and T2. Entire particle is in equilibrium state. What is the value of T1 and what is the value of T2? With the help of Lami's theorem, we have to solve this. Right? So let us see. Chudandi, for example, here weight is mg 90 newtons. This entire weight is balanced by the opposite, the force which is applied in the upward direction. So actually Lami's theorem prakaram మనం ఏం నేర్చుకున్నాం? F is directly proportional to sin theta. The ratio of magnitude of any force is weight here by angle in between the two other forces. ఈ weight కి opposite గా ఉండే two forces ఎవరు? T1 and T2. Then angle in between T1 and T2 it become 90 degrees. Angle is here 90 degrees, perpendicular 90 degrees. So W by sin 90 degrees, which is equal to magnitude of another force. Let us consider T1. Magnitude is T1 by sin of angle in between the two other forces of T1 కి ఉండే other two forces weight T2. ఈ two forces కి మధ్యలో ఉండే యాంగిల్ ఇది 90 plus 60. Simply you can write directly 90 plus 60 or 150 also ఎలా అయినా రాసుకోవచ్చు. And which is equal to దేనికి ఈక్వల్ అవుతుంది? Then the third force is T2. Magnitude of the third force is T2 and the angle in between the two other forces, that is T1 ki W ki weight ki మధ్యలో ఉండే యాంగిల్, here it is 90 plus 30. Now we have to calculate T1 and T2. సో ఫస్ట్ ఎప్పుడైనా సరే ఇలా లామిస్ థీరం బేస్డ్ క్వశ్చన్స్ కింద ఇచ్చినప్పుడు మన యాంగిల్ ని స్ప్లిట్ చేసుకుంటే ఈజీగా టెన్షన్ ఫోర్స్ ని క్యాలిక్యులేట్ చేయొచ్చు. రైట్ కదా? సో హియర్ W they gave 90 newtons by sin 90 value is 1, which is equal to, first ఈ two forces ని మనం ఈక్వల్ చేసుకుందాం. ఈ two values ని ఫస్ట్ ఈక్వల్ చేసుకుంటే 90 by 1 is equal to T1 is the subject by sin 90 plus 60 which is in the first quadrant, sin 150, sorry, it is in the second quadrant. In second quadrant sin is positive, sin become cos. గుర్తున్నాయి కదా మీకు, ఆల్ సిల్వర్ టీ కప్స్ All silver teacups lo, this is the first quadrant and it is second quadrant and it is the third quadrant and it is the fourth quadrant. Then in first quadrant all are positive, all silver teacups. In second quadrant sine and cosecant are positive. T, tan and cot are positive cups. Cos and secant are positive. So according to this, sine 90 plus theta, 90 plus 30 is in the second quadrant. In second quadrant sine is positive. And here for 90 degrees, 0 degrees, 90 degrees and then 180 degrees, 270 degrees. So operations will change. Eppudu change avutayi. Operations will change for 90 degrees and 270 degrees. Operations won't change for 0 degrees, 180 degrees, including the complete angle 360 degrees kuda operations change avvu. Right kada? So from that sin 90 plus 60 become cos 60 degrees. From this you can calculate T1. 90 is equal to T1 by cos 60 value is 1 by 2. Cos 60 sin 30. Both are equal 1 by 2. That implies T1 is equal to 90 newtons into 1 by 2 which is equal to 45 newtons. Simply. Now we can equate these two, first one and second one you can equate, or first one and third one also you can equate. First one and third one తీసుకుందాం ఈజీగా అయిపోతుంది. So that is weight again 90 newtons by sin 90 value is 1 is equal to, now we have to calculate T2 by sin 90 plus 30, 120 is again in the second quadrant. In second quadrant sin become cos 30 degrees. So that is therefore T2 is equal to 90 newtons into cos 30. Cos 30 and sin 60 both are same values, root 3 by 2. So which is equal to 45 root 3 newtons. So general ga manaku Lami's theorem with problems general ga T1 T2 ni calculate cheyamantaru. Right now with the help of the angles in between the two forces.